Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Danendra Zydean Mahardika. I'm from mechanical engineering, and in this video, I will discuss about mechanical fluids final test. There are 5 questions. So in this video, I will explain about question number one. Like the video will be a series video, so different questions will be on a different video. So in this video, I will explain about number one. Okay. So this is me, Muhammad Danendra Zydean Mahardika. You can call me Zide. So this is the framework of day 5. So we use conscious thinking, and then we use intentions, initial thinking, idealization, instruction set to solve the question. Okay, so on the intentions part, the challenge is this. This is the question. So is a flow through an orifice meter. So an air flow rate up to 1 meter cubic per second, and it got a manometer right there. So basically, we have to determine the head loss if the flow area at vena contracta is 0.65 of the orifice diameter. So this is the prayers. And as always, my favorite prayer is Allahumma la sahla illa maj'altahu sahla wa anta taj'alul hazna iza syi'ta sahla. Ya Allah, tiada yang mudah selain kau memudahkannya, dan kau jadikan kesulitan itu mudah jika engkau menghendakinya. Amin. Allah, give us the strength to understand the questions, help us solve the questions with the right solutions. I studied mechanical engineering at Universitas Indonesia to become a successful next generations that will succeed to bring a gold generation in Indonesia. With the knowledge of fluid mechanics, hopefully I'm one step closer to my goal. Please help us, Allah. Dare you for your guidance. As a human being created by God, I was given this perfect body, mind, and soul to be used for good deeds. Now I will use what God have given to me to solve fluid mechanics questions number 1. I will also explore easiness and maximum solving to these problems. So for question number 1, the initial thinking part. So from the question, the topic is about a flow through of a duct and an orifice meter. So there are also few variables that we know as such. So we know the rho is 1.23, the mu coefficient is 1.46 times 10 pangkat minus 5. The diameter 1 is 0.25, and the Q is 1, and the coefficient of orifice is 0.625, and the range is 0.30. So as you can see here, I already draw the orifice meter. So this is the vena contracta. So the vena contracta, as said from the question, is will be contracted through 0.65. So we have to find the head loss, right? So this is the direction of flow, so they are flowing right. This is the orifice plate, this is the manometer. So like there they have like two tubes that contains water. So basically it's like venturi pipe. It's quite like that. So these variables will help us find the right formula to find the orifice plate diameter and the head loss in the flow area. So that's all about the initial thinking part. We will go to the idealization part. So this is the idealization part. So the governing equations, we have 4 equations where we have the M, the flow rate equations, and then the pressure, the Reynolds number, and also the height. And after that, after we know all the variables that we need, we can now count the head loss using a basic a Bernoulli equations, another height equation, a force equation, and also a pressure equations. So there are a few assumptions that we made for these problems. There is percepatan times V, and also equal to 3, and then force B is equal to 0. Delta Z are neglected, uniform of flow and pressure at point A and point B, and also this is a non-slip condition, so this is no friction. Okay, Instruction set, I will demonstrate it on board. So I will write how my counting goes. So uh, from the first one, we have this. So we first can count the Reynolds numbers first because we need it to count the pressure. So we need the Reynolds number. So I will write RED1 rho V D1. If my writing is so bad, I'm so sorry. Okay, so it's quite hard to write on the whiteboard. For Q equal to mu V D1. So from here, and it's quite laggy, I think. But it's okay. So the mu is 1.46. Oh, I think we can screenshot it first. Um, no, I actually have a paper under me, so I know all the variables, so it, it is easier um to explain to you guys. Okay, so minus 5, and then the phi is just phi, just write a phi and 0.25 meters. After that, we write the rho, which is 1.23 times 4 and times 1. Okay, so from here we do an equation. I think you can just calculate it because it's easier, because we have like this is not a fixed number, right? So it's quite hard to count right now, so I already done my counting, and it's the total is 3.5 times. So we already know the Reynolds number, right? So after we know the Reynolds number, we will use this equation, the pressure difference equations. So like this. Oh, maybe I will make a box here. Okay. Question one. Box. I think that's all. Okay. So put a carbon. So we can substitute all the number now, like 1.23, 1 minus 0.74, 2, and then in the was it's quite laggy, you know. Okay, 0.625 times v times 0.75. Oh, it's very laggy right here. This is we have one. Yeah, I already also done the counting for this part, so you can just write it here. 2070 pascals. Uh, yep, that's about it, I think. And then the last one we will use the height equations formula. So we will get all the things that we need to count the head loss. Right? So basically, this is so, So this is 9.81 for gravity times 998. So raw water, you can just search it on Google. So raw water is about this. And this is 2070. Okay, so the result is I already have my counting also, so it's about 0. 0.211 0.211 meters. If you want to put it in millimeters, it's fine, you know. So it's about, yeah, it's about like this. Okay. So from there we know from the manometer that um, P1 minus P2 is about 4, 5, 30 pascals, and its height is about 463 millimeters, or 0.463 meters. Okay, so this is important, you know. This is important. So, if that is important, and also from that we can know that the final design of the orifice method is equal to 0.165 meter, and the B is 0.66. So this is also important to be noted, so we can do our next job. Okay, so we will get to the second part. So we will try, because we already know all the variables that we did, we can now find the head loss. So mm, I will try to find a way to make it, more. Okay, I think I'll put it right beside it. Okay, so for the head loss, so, so this is the head loss equation. So first we can put it put use these governing equations there. So I will write it down for you guys. So pressure to V plus a one volume, no, it's velocity, and plus minus pressure 3, 3 P3 plus GZ3, okay, equal to the height. Okay, so we'll learn the height, and from there we know that, like this this and this can be eliminated, because the assumption is uniform of flow and pressure, so there's no difference. And here we know that it's equal, so we can just get rid of it. So the equation will be like P1 minus P3. Oh, so the questions will be like this, more or less, and then from here we can change it. So we will change it to this height equation, from this to this. So yeah, from there we know that P1 minus P2 minus P3 minus P2 divided by, oh, it's very laggy right here, high LT. So we already know the pressure equation, right? So we can continue to find the governing equation. So use force equation as its governing equation. So this is important. This equation is important because we will use it to find the headless. Okay, so I will box it. Now for the force equation, so is Fs plus Fb equal to d per dt dt cv mu dv plus dv. So from here we know that this is equal to 0 because of the assumptions. This will also equal, we don't need to count that. Okay, so from that we know that Fs is equal to, so this is the equation. Now we can, after all the assumptions right here, we will get our last formula, which was P2 minus P1 times A1 equal to mu2 minus. Oh no, it's very laggy. It's quite laggy. I'm sorry, guys. So we will use this and this formula. Okay. From that formula, we know that. Okay, I might circle it. So we will use this formula and this. Okay, from there we know that this is this, and then we can rearrange it again. So it's B2 A2, so it's Q 0.65 B A1. So this is important. Then we can substitute all of it. I think we'll go more to the right. So this is pressure 3 minus pressure 2 is equal to rho Q2 A1 for that one 0.65 B minus 1. So basically it's 1.20. Oh no, it's only right here. So 1.23 times 1 quarter for, oh no, 4.25 for, so for the inside of the equation is about, this is 1, 0.65, 0.66, quadrat. So if I recall my counting also, so the total of pressure difference is about 1290 Newton per meter per square meter. So from that, we can use this, where is this, to find the height loss. So we will just substitute. So height of T is, you can use this or this one or this one. I think it's easier to use this one. So basically, we know that the pressure one is 2830 minus 1290 for the second pressure, for the third pressure. So divided by the rho. The rho is about 1.22. So after 1.23, oh, 1250 Newton per square meters. So after this, we know that the head loss is about, so pressure 1 minus pressure 3 is divided by pressure 1 minus pressure 2. So the answer is, so it's 1250 divided by 2830. So it's about 0.437. And so this is the head loss. So I think that's it from me for this video. So this is the answer. I will zoom out so you guys can see clearly. Sorry for the bad writing. So it's about like that. If you want it, I can screenshot it and put it in the in the end of the video. So that's about it. Thank you so much for watching this video. Question number 1. Expect another solving problems for questions number 2 until 4. Alhamdulillah. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.